Perpetual motion is one of the oldest and most seductive ideas in human history, a promise whispered across centuries that somewhere, hidden behind clever gears or secret forces, exists a machine that can run forever without fuel, without loss, without payment. The idea is simple and intoxicating: motion that never stops, energy that never fades, power without cost. From medieval inventors sketching endless wheels in candlelight to modern internet schematics claiming to defeat physics, the dream persists because it speaks directly to a deeper hunger, the desire to escape limits. A perpetual motion machine would mean freedom from scarcity, from labor, from decay itself. It would be the mechanical equivalent of immortality. But this dream collides head-on with the foundations of reality. Long before physics was formalized, careful observers noticed a pattern. Every machine slowed, every motion decayed, every system demanded input to continue. No matter how refined the craftsmanship, friction always appeared. Heat always leaked away, balance always failed. These observations were not philosophical opinions. They were empirical scars left by repeated failure. When classical physics emerged, it did not kill the dream out of malice, but explained why it must fail. The laws of thermodynamics did not arise to crush imagination. They arose because nature behaved the same way every single time it was tested. The first law states that energy cannot be created or destroyed, only transformed. This alone annihilates the most naive version of perpetual motion, machines that claim to generate more energy than they consume. The second law goes further and is far more cruel. In every real process, entropy increases. Energy spreads, degrades, becomes less useful. Order dissolves into disorder, not because the universe is hostile, but because that is how probability works at scale. Perpetual motion machines promise perfect efficiency in a universe that statistically forbids it. And yet the fascination remains, because perpetual motion is not really about machines. It is about control, about the refusal to accept that loss. Decay and limits are fundamental. In every era, new versions emerge dressed in contemporary language: magnetic motors, zero-point energy harvesters, quantum loopholes, vacuum engines. Each claims that old physics was incomplete, that a hidden exception exists, and each, without exception, fails when tested under controlled conditions. But the story of perpetual motion is not just a catalogue of errors. It is a mirror reflecting humanity's relationship with reality itself. We do not want endless motion because it is practical. We want it because it would mean the universe owes us something. In the next part, we will trace the earliest historical designs and see how even brilliant minds convinced themselves that clever geometry could outsmart nature, only to discover that nature does not negotiate. As centuries passed and mechanical knowledge advanced, the dream of perpetual motion did not disappear, but it began to face something far more dangerous than skepticism. Measurement early. Engineers and natural philosophers stopped asking whether a machine looked clever and instead asked whether it actually worked over time. When devices were observed carefully, a consistent truth emerged. No system maintained motion indefinitely without external input. Wheels slowed, springs relaxed, fluid settled, and gears lost momentum. Even in the best crafted mechanisms, these failures were not random accidents, but repeatable outcomes. This shift from imagination to observation marked a turning point when science matured in the 18th and 19th centuries. These accumulated failures were no longer treated as individual mistakes, but as evidence of universal behavior. This is where thermodynamics was born, not in abstract theory, but in the brutal reality of steam engines, where inefficiency meant lost money and wasted fuel. The first law of thermodynamics formalized what experience had already shown. Energy is conserved. It cannot be summoned from nothing, nor can it vanish. It can only change form. This immediately destroyed the possibility of perpetual motion machines of the first kind, devices that claimed to produce more energy than they consumed. No refinement, no hidden mechanism, and no exotic material could change this, because the limitation was not technological, but fundamental. The second law delivered the final verdict. It revealed that even if energy is conserved, its quality is not. With every transformation, energy becomes more dispersed, more disordered, less capable of performing useful work. This tendency is measured as entropy, and it always increases in real systems. Friction, heat loss, air resistance, internal vibrations. And molecular interactions are not flaws to be engineered away. They are unavoidable consequences of matter itself. A machine might run smoothly for a time, but it must always lose usable energy to its surroundings. This makes perpetual motion machines of the second kind impossible, as they would require converting ambient heat entirely into work without losses, an outcome nature statistically forbids. At this moment, perpetual motion ceased to be a scientific problem once these laws were experimentally verified across countless systems. There was no longer a need to test individual designs. Machine that claimed endless motion was already disproven before it was built, not by disbelief, but by the accumulated weight of reality itself. As the laws of thermodynamics closed the door in theory, the belief in perpetual motion retreated into design. Inventors no longer claimed to violate physics openly. Instead, they claimed to outsmart it with geometry, weight distribution, and clever timing. From medieval overbalanced wheels to intricate systems of levers, fluids, and magnets, the promise was always the same: motion sustained not by energy input, but by arrangement. The most famous designs relied on asymmetry. Wheels weighted so that one side was always heavier than the other, creating the illusion of constant torque. At first glance, these machines seemed convincing, especially when examined in static drawings or short demonstrations. Yet, once built and observed over time, the truth revealed itself. The weights that appeared to provide extra force on one side required equal energy to be lifted on the other. Any gain was precisely cancelled by the cost of resetting the system. Gravity, so often invoked as the hidden power source, was shown to be neutral over a full cycle. It gives no free advantage. It only stores and returns energy that must be paid for in advance. Other inventors turned to fluids, imagining self-circulating pumps that would raise water using the pressure created by the water itself. These designs ignored losses to turbulence, viscosity, and heat, which silently consumed the system's energy until motion ceased. Magnets later replaced weights and water in modern schemes, promising invisible forces that could push without being pushed back. But magnetic fields obey the same conservation laws as every other interaction. Any force exerted must be balanced elsewhere in the system. What appeared to be continuous motion was always the slow release of stored energy, not creation. In demonstrations, devices were often spun by hand, hidden springs were wound in advance, or motion was sustained briefly by external vibration. When isolated and measured carefully, they always failed. This pattern repeated across centuries, not because inventors lacked intelligence, but because human intuition is poorly suited to understanding closed systems. The mind focuses on the moment where motion seems to gain, but ignores the full cycle where the cost is paid. Perpetual motion designs survive because diagrams lie more easily than experiments. Once time is allowed to pass, and energy is accounted for honestly, even the most elegant geometry collapses into stillness, reminding us that nature does not reward cleverness, it rewards consistency. When clever design failed, perpetual motion did not disappear. It transformed. What could not survive honest testing learned to survive. Belief history is filled with inventors who did not merely misunderstand physics, but actively blurred the line between self-deception and fraud. Traveling demonstrations became common, where machines were shown running behind glass cases, under tables or inside sealed boxes, always just long enough to convince investors, but never long enough to allow proper inspection. Hidden weights, compressed air tanks, coiled springs, and external power transmitted through floors or walls sustained motion briefly, creating the illusion of autonomy. Once money changed hands, the inventor vanished or blamed. Sabotage, entire fortunes were lost to devices that worked only until scrutiny began. In some cases, the inventors truly believed their own claims. They mistook stored energy for generated energy and confused delayed loss with absence of loss. This psychological trap proved powerful because the human brain is excellent at spotting apparent gains and terrible at tracking invisible costs over time. Faith replaced measurement, and testimony replaced data. In the 19th and early 20th centuries, patent offices were overwhelmed with perpetual motion applications, forcing governments to establish rules rejecting any device claiming infinite energy without experimental proof. Even then, belief adapted. Instead of denying thermodynamics outright, new proposals claimed exceptions, special materials, undiscovered forces, or privileged reference frames. These machines were said to work only under precise conditions and to fail mysteriously when outsiders examined them. This pattern mirrored religious thinking rather than scientific inquiry. The device always worked somewhere else, for someone else, under circumstances that could never be reproduced. Yet, society continued to tolerate these claims because they offered hope in a universe governed by limits. Perpetual motion became less about mechanics and more about rebellion against entropy itself. To accept its impossibility is to accept that decay, loss, and effort are fundamental features of existence. Fraud exploited this discomfort mercilessly, packaging eternal motion as liberation from work and dependency. Each failure was explained away, never accepted. The machine was never wrong. Reality was. This mindset ensured that perpetual motion survived not as engineering, but as myth, where it could not be disproven, because myths do not require consistency, only belief. In the modern era, perpetual motion did not vanish. It learned a new language as classical mechanics and thermodynamics became widely taught. Claims of endless energy adapted by hiding behind advanced terminology. Magnets replaced weights, quantum mechanics replaced gears, and vacuum energy replaced steam. The promise remained unchanged, but the vocabulary evolved. Magnetic motors were presented as systems where attraction and repulsion were supposedly unbalanced, creating continuous rotation without input. What these designs ignored was that magnetic fields are conservative. Any energy gained moving with the field must be repaid when moving against it. The cycle always closes. With zero net gain, quantum mechanics provided an even more seductive shield. Zero-point energy, virtual particles, and vacuum fluctuations were invoked as proof that energy exists everywhere and can be harvested freely. What was left unsaid is that these phenomena do not represent extractable work. They are statistical features of quantum fields, not reservoirs that can be drained without consequence. Any attempt to extract usable energy destroys the very conditions that allow those fluctuations to exist free. Energy devices began appearing online, wrapped in oscilloscope screenshots, blurred measurements, and selective demonstrations. Videos showed spinning disks, glowing coils, and unexplained outputs, but never full system boundaries or long duration. Tests, control experiments were absent. Independent replication was dismissed, and critics were labeled closed-minded or corrupt. This was not science. It was performance modern. Perpetual motion claims thrive in environments where complexity intimidates skepticism. The more advanced the language, the harder it becomes for non-experts to challenge false assumptions. Yet when examined by physicists, engineers, or metrologists, these devices collapse instantly. Hidden power sources, measurement errors, misinterpreted waveforms, and thermal gradients explain every result. With perfect consistency, no verified experiment has ever demonstrated net energy gained from a closed system. The modern myth persists because it exploits a gap between scientific literacy and technological awe. Perpetual motion now wears the mask of progress, pretending to be suppressed by institutions rather than constrained by reality. In truth, if such a device worked, it would not be hidden. It would dominate the world within months. The fact that it never does is not evidence of conspiracy, but proof that the laws discovered centuries ago remain undefeated. Despite centuries of failure, refutation, and exposure, the idea of perpetual motion refuses to disappear, not because evidence supports it, but because human psychology sustains it. The promise of endless energy appeals to something deeper than engineering. It speaks to discomfort with limits, with effort, with the certainty of loss. Every real system demands maintenance. Every achievement decays, and every gain carries a cost. Perpetual motion offers an escape from this reality, a fantasy in which progress is permanent and debt is erased. This makes the idea emotionally resilient, even when it is intellectually defeated. Cognitive biases reinforce the illusion. People remember the moment a machine starts spinning, but forget the preparation that made it possible. They notice motion, but ignore time. They assume that complexity implies depth, and that unfamiliar language implies hidden truth. When a device fails, believers rarely abandon the idea. They adjust the explanation. The machine was almost complete. The materials were wrong, the conditions were imperfect, or the observer interfered. This creates a self-sealing belief system, where failure becomes evidence of suppression rather than error. Social dynamics amplify the effect online communities form around shared belief, where doubt is treated as hostility and agreement is rewarded with belonging. Perpetual motion becomes an identity rather than a hypothesis. History shows that similar patterns appear whenever a claim promises total liberation from constraints. Eternal youth, limitless wealth, and perfect knowledge all attract followers despite repeated disconfirmation that the mind prefers hope over accuracy when the cost of hope feels low. In the case of perpetual motion, the fantasy carries no immediate penalty for belief, only for action. Yet there is a deeper reason the idea persists. It reveals a misunderstanding of what science actually is. Science is not a collection of opinions waiting to be overturned by a clever exception. It is a process that compresses reality into rules that survive relentless testing. Thermodynamics did not ban perpetual motion by decree. It described the universe so accurately that perpetual motion had nowhere left to hide. To reject those laws is not rebellion. It is isolation from accumulated knowledge. And still, the dream lingers because it is easier to imagine a universe that owes us abundance than to accept one that demands balance, effort, and humility. Perpetual motion survives not as a machine, but as a mirror, reflecting humanity's eternal struggle to accept that some limits are not temporary obstacles, but permanent features of existence. In the end, perpetual motion fails not because humanity lacked intelligence, creativity, or persistence, but because the universe keeps perfect books. Every interaction is accounted for. every transfer balanced, and every cycle closed. The history of perpetual motion is therefore not a history of bad engineering, but a history of learning where the boundaries truly lie. What began as mechanical curiosity evolved into one of the most important lessons science ever taught, that limits are not enemies of progress, but its framework. Once energy conservation and entropy were understood, engineering did not stagnate. It advanced faster than ever by accepting loss. Humans learned to minimize it. By accepting limits, they learned to work within them. Thermodynamics did not end innovation. It made innovation honest. No machine can run forever without fuel. But systems can be made more efficient, more durable, and more intelligent, precisely because their constraints are understood. The myth of perpetual motion promised a shortcut, and shortcuts always collapse under scrutiny. Real progress has always come from confronting reality rather than denying it. The desire for endless motion reflects a deeper wish for permanence. In a universe defined by change, yet meaning does not arise from infinity. It arises from finitude. A machine that never stops would be useless, because value exists only where resources are limited and time matters. Perpetual motion would erase cost, and without cost, there is no choice, only noise. The true triumph of science was not proving that perpetual motion is impossible, but showing that the universe is comprehensible, consistent, and fair in its accounting. Nothing is stolen, nothing is free, and nothing is lost without trace. In accepting this, we gained something far more powerful than an impossible machine, the ability to predict, build, and understand a world that does not bend to desire, but rewards understanding. This is why perpetual motion belongs not to the future, but to history, as a necessary illusion that guided humanity toward deeper truth, by showing that even dreams must obey the laws of reality.